This is Geometry, Unit 3 on Congruence, Section 1, Congruence Transformations. We just got done with a unit talking about transformations, so we should know everything there is to know about rotations, reflections, translations. So let's just talk about what a congruence transformation is first off. A congruence transformation means that the position of the image may differ from the pre-image but the two figures remain congruent. This is also called isometry. It's another name for it. Now, when we did transformations last unit, these were the types of transformations we did. We did congruence transformations. Okay, so this is a little bit of a review of what we remember about it. So here we have three graphs of an image and the pre-image, and we want to decide what type of congruence transformation it is. Is it a reflection, is it a translation, or is it a rotation? So our first one, we have two triangles being shown. Here's one of our triangles, here's the other. And how are those two images being transformed? Well, that is clearly a rotation. We see that the image was definitely rotated, so this would be a rotation. The second image, we have two different quadrilaterals. Here's our image and our pre-image. And if we take a look at those, that is definitely a reflection. It's definitely a reflection across the x-axis. So this would be a congruence transformation of a reflection. And our third diagram here is two different triangles, a triangle ABC and DEF. And take a look that they are not rotated or reflected, but instead it looks like they were translated down. So this is our transformation of translation. So just being able to identify it. And once again, we just learned this, so this should be pretty simple and straightforward. So now what we're going to do is we are going to graph two images. We are going to identify the transformation, and then we're adding something on, verify that it's a congruence transformation. We'll talk about exactly what that direction means in a minute. So let's first graph. So here we have PQR. So P is at 4, 2. Q is at 3, negative 3. And R is at 5, negative 2. So P, Q, R. Second triangle, J is at negative 2, 0. K is at negative 3, negative 5. And L is at negative 1, negative 4. So J, K, L. So when we take a look at these two images, it appears as if this is a translation. It looks like we went 1, 2, 3, 4, 5, 6 to the left and 2 down. 1, 2, 3, 4, 5, 6 to the left and 2 down. And that's consistent for all of the points. It's 6 to the left and 2 down. So this is definitely a translation. Now, whenever we verify something, that means we need to give some reasons and some proof as to why. So here, to verify that it's a congruence transformation, we want to verify that the lengths of all the sides remain the same. So we want to verify that the length of PQ is indeed still equal to the length of JK. We want to verify that the length of PR is still equal to the length of JL. And we want to verify that QR is equal to KL. Well, to do that, we can use the distance formula or the Pythagorean theorem to do this. We'll do the distance formula. And remember, there are numerous ways to do the distance formula. You can use the full blown out formula of x2 minus x1 squared plus y2 minus y1 squared and take the square root of that. Or because we know x2 minus x1 and y2 minus y1 is just talking about the change of values, we can view this as how much do your x's change and square it, and then add on how much your y's change and square it. We'll do it that way. So from P to Q, when we are looking at our points from P to Q here, here's P, here's Q. Our x's change from 4 to 3, they change 1, so it's 1 squared, plus our y's change from 2 to negative 3, 5, so 5 squared. 1 squared is 1, 5 squared is 25, 1 plus 25 is 26, so PQ is the square root of 26. JK. From negative 2 to negative 3, our x's change 1, so 1 squared, plus from 0 to negative 5, our y's change 5, so 5 squared. So 1 squared is 1, 5 squared is 25. When we add those two together, we get the square root of 26. So here, PQ is equal to JK. We verified it. There's our work. All right, PR, let's see if that's equal to JL. So from P to R, 4 to 5, our x's change 1, so that's 1 squared, plus 2 to negative 2 is 4, so 4 squared. 1 squared is 1, 4 squared is 16, so that's the square root of 17. J to L, negative 2 to negative 1 is 1, so x's change 1, 1 squared. Y from 0 to negative 4 is 4, so 4 squared. 1 plus 16 is 17, so that's the square root of 17. So those two are indeed equal. Those are equal. There's our steps for verifying. Last but not least, QR, does that equal KL? Q to R, 3 to 5 is 2. So our x's change 2, so 2 squared. Negative 3 to negative 2 is 1. So our y's change 1, so 1 squared. 2 squared is 4, 1 squared is 1, 4 plus 1 is 5. So QR is the square root of 5. K to L. Negative 3 to negative 1 is changes 2, so 2 squared for our x's. Negative 5 to negative 4 changes 1, so 1 squared for our y's. 2 squared is 2 squared is 4, 1 squared is 1, 4 plus 1 is 5. These are both the square root of 5, so those are also equal. There's our work. So there we verified that it's a congruence transformation. So not only do we have to say that this is a translation, we also need to show that the three sides do end up being the same, and there is our work for showing it.